Okay, recurrence relations, they look really scary, really impossible. Ooh, but they're actually really easy. Okay, we're going to start here with this one here. They will always give you a starting value. Now notice they've used X. They can use any single letter they like. So they could use U to the 1 or K to the 1. And basically X to the 1 means our first term. So our first term is X to the 1, which is 2. And what we're being asked to find is X to the 4. So we want to know our second term, X to the 2, or they could use U to the 2 or K to the 2. And we want to find our third term, and we want to find our fourth term. So that's what we're interested in finding. Now the formula looks horrific. It's actually really, really simple. So what we're going to do is, the first thing we're going to do is, wherever you see an X to the N, that is your feed. So that's where you're going to feed your first value. So when you feed the first value, we're going to get 2 lots of X to the 1. So we're going to make him a 1. So 2 lots of 2 plus 5, which gives us 2 times 2 is 4 plus 5, which gives us 9. Now what are we actually doing if we feed in X to the 1 into that X to the N? Well, we're actually getting, if we think about it, X to the 1 plus 1, which actually gives us X to the 2. So X to the 2 is 9. So what I want you to think of is, I'm going to rub all that out to make that a bit easier. So this is the feed, the X to the N part, and where you see X to the N plus 1, this gives you the next term. Now, the reason that they're called recurrence, in fact, let's come back to that bit. Let's do the next one and then I'll show you the reason why they're called recurrence. So to get X to the 3, we're going to feed the 9 into the X to the N. So we're going to get 2 times 9 plus 5, which is 18 plus 5, 18, is it 23? But check my maths. And then to get X to the 4, so X to the 3 is 23, and to get X to the 4, it's 2 times 23 plus 5, so that must be 46, that must be 51. And there's your answer. Now, why are they called recurrence? Pretty obvious. If something recurs, it goes round and round and round and round and round and round and round. So you can see that actually what we've done is we've just fed it round and round and round and round and round again. Easy, easy, easy. Okay, you try these ones. Don't worry about the fact that they're U's. They could be any letter. I used X's in my example, but you've got U's. So this one, let's get the pen on. U1 is 4. So this here is the feed. All right, that's the feed. And this one here is the next one. Okay, so U1 is 4. So to find U2, we're going to do 4 plus 5, which gives us 9. Okay, to find U3, we're going to do 9 plus 5, which gives us 14. To find U4, we're going to do 14 plus 5, which gives us 19. And to find U5, we're going to do 19 plus 5, which gives us 24. There we go, done it. U5 is 24. Done. One. Okay, it's U's again, it's not K's. So, this time here's the feed. Right, there's the feed. And this one is the next one. Okay, here's my starting. Now don't panic, it's a K, not a number. Okay, so U to the 1 is K. So to get the next one, I'm going to feed it into there. So I'm going to get 1 minus 4 lots of K. I'm going to pop a bracket around that. Okay, to find U3, I'm going to feed the one that I've just found, which is this one, into the feed. Okay, so 1 minus 4, lots of the one I've just found, so 1 minus 4K. And then I'm going to times it out, which gives me 1 minus 4 plus 16K, which gives me 16K minus 3. So U to the 3 is 16K minus 3. Done.